Mm, okay. Right. So a database management system includes capabilities and tools for accessing and managing data in a database. Yeah. So database management system, it includes all these capabilities and tools to access and manage data in that database, right? So what are these capabilities or tools available? One thing is data definition language, right? Used to specify the structure of the database contents, creating and defining tables and fields. Yeah. So basically, data definition language means it's something that is used to specify the structure of the database content, right? So basically it defines the structure of the database, right? And then create and define, creates and define tables and the fields, right? Then we have a data dictionary, another tool, an automated or manual file that stores definitions of data elements and their characteristics. Yeah. So in this data dictionary, it's actually maybe a manual file or an automated file, right? Which stores uh, basically store the definitions of these data elements and their respective characteristics, right? And then we have the data manipulation language. So it's a specialized language such as structured query language, SQL, right? So I think you have heard about this SQL, right? So it's a language which is used to manipulate this data, add data, delete data, so edit data, retrieve data. So anything can be done using this data manipulation language. So that's the most closest language out of these three uh, tools, right? Okay. Then we'll discuss about logical and physical views of data, right? The physical view of data cares about whether, the physical view of data cares about where the data are actually stored in the record or in a file. So I told you the actual database is known as the physical view, right? Does it really matter to the user that the uh, customer address is physically stored on the disk before the customer name? Yeah. So does that matter? So I mean, to have the customer address to be stored before the customer name, so it doesn't matter for the user. As mm, if the user can retrieve the data as he wants, then the order won't matter to him, right? However, when users create a report of customers, they generally will list the customer name first and then the address. Yeah. So it generally happens not because you initially store the name, right? Then only address comes. So logical view is more important to the end user. Yeah. So because through the logical view only these customers are actually accessing this data. So that's why logical view is much more important because the end user doesn't worry whether this name or the address which is stored first. He only wants the information and data, right? Data. So that's why. So the most important thing for the end customer, the user, is the logical view. Now we'll discuss about designing databases. Right. So under that we'll discuss about relational data model. Right. Relational data model organizes data into tables of columns and rows. So I think you already have seen such data tables, right? So in relational data model, what happens is, so they organize this data into tables of columns and rows, right? So in column wise, you have these attributes or the fields, right? And row wise, you have the records, right? Generally, each table represents one entity type. So normally these tables are used to represent one entity type. Entity type means maybe there's one, what you call a table to enter records of students, right? Columns represent attributes. So as I told you earlier, columns are used to represent the attributes or the fields, right? Rows represents records. So all those records are stored row-wise, right? Each row has a unique identifier called primary row. So we discussed that earlier also. So in order to access each of these records, right, there should be a unique identifier. So that is known as the primary key. So in the scenario of a student, student ID is unique. So it can be considered as the primary key, right? Okay. So I show you this example, right? Sorry for that. So this is the customer table, right? So so these are the columns. So these are the columns, right? So you have 5 columns, and these columns are attributes: customer ID, name, phone, city, account balance. These are attributes of fields, right? And what are these? 1, 2, 3, 4, 5. These, I mean, row-wise, these rows are actually what you call the records, right? So out of this, what's the unique item? So that is the customer ID, right? So unique field is customer ID. So this is the primary key. So this is the primary key of this record, and this is the primary key of this record. So customer ID is the primary key of this particular customer table because it is unique, right? Okay. When one table is related to another, primary key from one table is stored in the second table as a foreign key. Yeah. So by the name itself, you can understand this is a relational data model. That means different tables are related with each other, right? So if we consider two tables like customers and orders, right? So you can see in orders, in terms of order, you have first the order ID and then date and the customer ID and amount. So you can see, because when you store this order information, or every time you enter these orders, you don't need to put customer's name, no, right? You just can have the customer ID, right? But in another table, as customers, you can define name, phone number, address, right? Facts, whatever that is related, or the gender maybe, right? So any attribute related to customers can be stored in a separate table. So you can see anyway. So you want use all these fields in this table. There's no point, right? You can just have them, then it will be redundant because the same data is available in many places. So instead, what you do is you have a separate table. So it's easy, right? So this is the order table, but those things are related how using this attribute. So this is the primary key of, so this customer ID is the primary key of customers table, right? Like student ID is the primary key of student table. Likewise, customer ID is the primary key of customer table. And this will be a foreign key in the related table, right? So the primary key of the customer table is a foreign key of the order table, right? So, so when you look at this first record in this orders table, so you can see 150 is the ID, and then date is October 1st, and then 250 is the customer ID, and amount is 788.8 rupees and 50 cents, right? So in that scenario, 250 is the customer ID. So from this table, it will be related to the, through this field, it is related to this customers table. So you can see by referring to this ID, so what's the customer's name? It's Anna. So her phone number is given. Likewise, you can relate, right? So this primary key, foreign key concept is so important in designing these relational databases to prevent data redundancies, right? Okay. The ideal relational database will have many small tables, not one a big one. Yeah. So as I told you earlier also, a good one, an ideal relational database won't have this big, just one big table, because for an example, if you are going to have all the customer details in this order table, then that's not a good database, right? So in an ideal relational database, so you will have small tables which are related with each other, right? This is especially helpful in reducing redundancy. As I told you earlier, data redundancy will be minimized and increasing the usefulness of data. So the usefulness of data is improved, right? Relational databases are becoming the most popular because they are easier to work with. So they are easier to deal with, easier to change, can serve a wider range of needs throughout the organization. So relational databases are much more important nowadays. Okay. Then database trends. So in terms of databases also, there are some trends. For an example, we have distributed databases. So what's this? A database in which not all storage devices are attached to a common computer. Yeah. So a distributed database means they are all these devices are not attached to a common computer. Distributed means everywhere these devices are distributed, right? Through the database, but the database can be accessed from all these devices, right? Because so the database, the data will be stored in multiple computers located in the same or different physical locations. But anyway, overall, in the database, so database is not actually a physical thing. No? We use computers and all these things to software. Software is also not physical. So hardware, everything is used to store this, enter this data. That's true. But anyways, database is not the physical. So physical thing. So this database is available, can be available in many places because different computers have been combined together, right? Multiple computers are used to store all this data, right? So may be located in the same place, but can also be located in different physical locations as well. That's not an issue for the database. Keeping everything consistent is a very complex task. Yeah. So to keep everything consistent, that means when something is changed in one particular place, that has to be updated in other places also. This is not a simple task. It's very complex, right? These are usually found in very large corporations that require multiple sites to have immediate fast access to data. So that's why in these huge organizations, right, they have these multiple sites to have immediate and fast access to data because they tend to take advantage of these distributed databases, right? In a second, and also the users are capable of retrieving this data in a second's time, right? Okay. Then there's another database type known as object-oriented database, right? So, in traditional databases, what happens is they store data as text in fields, no? Right? So we have these text strings, right? Object-oriented databases allow storing data as objects. Have you heard about this double OP, object-oriented programming, and double OP, any other object-oriented anything? So it's a totally different topic anyway, right? Anyway, are you learning programming languages also? Just can one of you talk? Nobody's talking, so I'll assume that you know about object oriented, right? So like object oriented programming in object oriented databases. So these data will be stored as objects, not as text fields, right? Just as text fields, but they will be stored as objects. Can be integrated with the programming languages, so objects can be directly saved and read. So here, as I told you earlier also, so you can use the languages that adhere to OOP concepts can be used to save and read these data objects. Right. Then we have data warehouses, right? So data warehouses are a large, somebody has put that, basic programming in Python, but mainly for data visualization. Yeah. So have you learned anything about OOP? Anyway, it doesn't matter, right? So mm, just instead of these what you call as text fields, just you store data as objects, right? Everything is seen as an object, right? So so it's just to know about those facts, right? So no need to worry that much if you don't have much of an idea in terms of OOP, that's fine, right? So it's not related to here. Just to mention that there are these sort of databases available, right? Then a data warehouse. So it's a large store of data accumulated from wide range of databases within a company used to guide management decisions. So you can see, so this is a data warehouse. So you can see different databases are combined together, right? So supply chain, billing, ERP, CRM, so all these databases are combined together, right? And stored in a data warehouse, right? So through this data warehouse, it's easy to do reporting, visualization, then BI. So everything can be performed because if all these databases are collected together, accumulated together, and a data warehouse is and stored in a data warehouse. So through the data warehouse, it's easy to visualize and make reports. So everything is possible because everything is available in a one place, right? So none of these things are physical actually, right? So these are just you know you can say programs, right? So the things that cannot be touched, right? But it's available. They are available. Then we'll discuss about management requirements. The critical elements for creating a database environment are, So if you want to create a database environment, there are some critical elements that you need to consider. There should be data administration. Data administration means you need to administrate what are the important data, right? So basically how to control this data. So data, just having the data won't, as we discussed earlier also, won't let an organization to, you know, utilize them in an effective manner, right? So data administration is required, right? Data planning and modeling methodology, So there should be some sort of a planning about data and also how those data should be used, changed, right? Modeled means change basically, right? So how those data can be used to get valuable information, right? Database technology and management. So in terms of database, what's the technology we are going to use? How we are going to manage them? And who are the users who are using this database management system, right? So these are the critical elements that should be considered when developing a database management system. For a database management system to flourish in any organization, data administration functions and data planning and modeling methodologies must be coordinated with database technology and management. So as we discussed earlier also, so it's more important to combine all these functionalities together, data administration, data planning and modeling, right? And then database technology and management. So all these functionalities should be coordinated together in order to take advantage from a database management system, right? Resources must be devoted to train end users to use databases properly. So anyway, end users have to use these databases, so they have to take advantage from that. So in order to do that, resources must be devoted or used to train these end users. If the users don't know how to use a database properly, then there's no point, right? So resources must be allocated to train these people. So we'll discuss about data administration. The organization must develop a data administration function with the power to define information requirements for the entire company and with direct access to senior management. So in any organization that is going to have a database management system, there should be a data administration function, right? So this data administration function is there to define information requirements. So that means what are the information requirements this organization has, right? So this will be done. This will be decided with the help of senior management, right? So basically, data administration function in any organization is responsible for developing information policies. So in terms of information, the policies should be defined, right? So that should be done by data administration. And then planning for data. What are the data we require and how we are going to plan available data? So these planning for data should be also done by data administration. And then overseeing logical database design. So the logical database design should be logically seen by the data administration, right? What sort of a database design we are going to have. So it should be logically seen by the data administration, monitoring the usage of data. And then in terms of usage of data, that should be monitored, right? Or controlled, right? The fundamental principle of data administration is that all data are the property of the organization as a whole. Yeah. So the fundamental principle of data administration is that all the data that is available, so it should be, the data should be considered as a property of the whole organization, not an individual's or a group of individuals property. So data is the property of the whole organization. Data cannot belong exclusively to any one department. Yeah. So like in traditional database management database systems, right? So you should not think that data is exclusively belong to one just one department, one or two departments, right? So it belongs to everyone. All data should be available to any group that requires them to fulfill its mission. Yeah. So this data should be available to any group that requires the data, right? The information policy should outline how data will be shared, maintained, distributed, and updated. Yeah. So the information policies that are defined by the data administration should outline how data will be shared, maintained, distributed, and updated. Right? Yeah. Then we have data planning. Right? The organization requires enterprise-wide planning for data. Yeah. So at an enterprise level, right? So some sort of planning is required for this data. So what should be done for this data? Right? Enterprise analysis, which addresses the information requirements of the entire organization, is needed to develop database. So before developing a database, right? So enterprise analysis is required. So basically through that, actually, information requirements of the organization is met, right? Not just the requirements of one department or application. Yeah. So it's not going to focus on just a single department or an application, but overall organization will be taken into account. Should identify the key entities, attributes, and relationships that constitutes the organization's data. So as we discussed earlier, under data planning, right, we have to focus on what are the entities we are going to have. So for an example, attributes, entities in a university may be students, right? And then academic staff, likewise. So those are the entities. And then what are the attributes there? For an example, students, student ID, name, then email, likewise, right? And what are the relationships among these tables that we need to have? So all these should be planned under this data planning phase. Then what is database technology management and uses? Databases require new software and a new staff specially trained in database management system techniques as well as new data management structures. Yeah, so any database management system require new software, right? Now software and new staff. New staff means actually even trained staff is okay to use these database management techniques, right? So that means to effectively take advantage from the database management system, right? Users need to understand the role they play in treating information as an important corporate resource. Yeah. So all the users should know that information is considered as an important corporate resource, right? They require user-friendly structure for the database and lots of training. Yeah. So in order to, because they are not software engineers or programmers, no? So they just retrieve and delete, edit, all these functionalities will be done. So that's why they need a friendly user interface, right, to deal with the database, right? And also lots of training should be provided because if they are new to that, right? Okay, so that's the end of the lecture. So you see, actually these are so small lectures. So if we didn't have the what you call that issue in rejoining, and again I started the lecture around 1:15, started around 1:20, right? So yeah, if we started by 1 o'clock, then we could have stopped it by 2 o'clock. So it's just a matter of 1 hour, right? Maybe less than that. So so it's not that of a big deal, right? So just participate for the lecture. So then it will be motivating for us even, because if we have like from a batch of 90 people, if we have only like 15 people in the lecture, then it's so demotivating. So today I thought you will all join the lecture. So then, as a result, I had a quiz earlier in this lecture, but I removed it. So anyway, you have to do a group project, right? So it's a small group project. So basically these are the requirements, or the guidelines for that. Select a type of management or enterprise information system. Examples are inventory control, invoicing, CRM, HRM, EMS, post, whatever that is convenient for you. Find an application of that type. Select a business scenario that kind of information system can be used. Present and demonstrate to the class how this system can be used effectively in the selected business scenario. Right? So the group size should be 4 to 5 people. So presentation or the demo should take only like 10 minutes, maximum 15, right? So, so I want you to do that, like, so it's not that of a big deal, right? So, shall we have that next week? Yeah, so basically you are supposed to form groups first, right? So like 4 to 5 people, that is 4 or 5 people, right? So since your batch is composed of 90 students, right? 90. So if you go with 5 people per each group, then it will be 18 groups, no? So that will be convenient, right? So Uvini, so that's the only name I remember.
Yeah.
You are the rep, no? Yeah, so you have 90 people, right, in your batch?
97.
In the 97. Okay, then 4 or 5. 4 or 5 people per group. So if we are to have 4 people, then 96, no? So one group will have 5 people. So 97, 96 is divisible by 4, right? So it's 24. 24 groups, and then the final group, yeah, 24 groups. So 23 groups are going to have 4 people, and the remaining one will have 5 people, something like that. Or maybe you decide, but anyway, don't let like some people not to have groups. So sometimes it happens, right? So you collect all your favorite people together, maybe 5 each, and they are after some like 2 or 3 people will be there isolated, right? So don't let that happen. So you decide, you can decide that. So so the maximum group number will be anyway 24, no, right? So having less than that will be easy for me, right? So anyway, so I want you guys to decide form groups and update in a Google Sheet, right? Your group, give a name for your group, right? A sensible one. Mm, I mean, can be funny, that's fine, right? So, mm, and then you can jot down what are who are the participants. I mean, who are the group members, right? Indicate their index numbers maybe in a Google sheet, right? So don't let your representatives to work that hard because of you. So support them. Just so what you need to do is, so maybe one of the representative can create a Google sheet, and you have to go there and update. So that's a simple task, right? So please do that. And so after the lecture, next week after the lecture, we'll have these presentations, right? So um, so I believe like, so it's a matter of like 10 to 15 minutes now. So like from each group, 1 or 2 people can present. But anyway, I'll ask, when I want to ask questions, I'll ask from everybody, random, in a random manner, right? So we'll do like that. It's a small group project. So I'll upload the slides as well and the recording. So if you have any issues, just let me know. And regarding that previous week quiz, I'm going to give marks for the people who have emailed me asking, mentioning their usernames, right? In Zoom display names and the emails. And when you name, you could have at least named your what you call the document in the way I asked, so that won't be a problem for us. Anyway, that's fine. I'll give one chance. Right. So we'll do like that. So we'll have the project demonstrations by the next week. Yeah. So that's all for today. Right. Thank you.
One last thing.